today we are going to discuss about the topic is binary search. So before going to discuss about binary search, first of all we have to know what is the meaning of search. Search means a given array. Array contains some elements. So in that elements we need to take one more element that should be is present in the array or not. So we are searching that element in present in the array or not. If it is present, then we are going to display the position of the element is present, in which position the element is present in the array. Suppose the array, in that array elements, the searching element is not there, then we are going to display the output is the search element is not present in the array. So that is about searching. So this searching can be has been divided into searching can be as two methods. One is linear search and second one is binary search. So but today we are going to discuss about binary search. So very important topic in the very important point in the binary search here. Binary search can be applied only for the sorted array elements. I am writing this note. Binary search can be applied only for sorted array. Only for sorted array. This is very important point. Binary search can be applied only for sorted array. So now we have to discuss about the steps. What are the steps? We have to discuss it right now. Now steps. So initially we have to take some variables. Low is equal to 0. That means first element. High means last element. I means n minus 1. So we need to calculate, second step we need to calculate middle. So how to calculate middle? We can take mid also. Low plus high by 2. So initially we know that what is low, what is high, and finally we got middle also. Now we need to compare. Comparison starts here. Compare. Suppose the search element is x. So if a of x is equal to a of x is equal to a of mid. If this is the first one, compare. If a of x is equal to a of mid, then search element is present in middle position. Search element present in mid is present in middle position. Mid position. So if what is the meaning of that? The middle element and search element we are simply we are taking x. X is present. X is equal to middle. Then the searching is completed. Suppose it is not equal. It is not equal, either less than or greater than, what we have to do? Right. If x is greater than a of mid. X is greater than a of mid. That means, so now x is greater than with middle means we need to compare only right side of the array. Not need to compare the left side of the array. Then we are going to change. Then change low is equal to mid plus 1. Low is equal to mid plus 1 and we need to do the compare. Suppose if x is less than a of mid, that means what is the meaning of that? The search element is less than left side of the array. Compare with the middle element less than. So middle we need to do the comparison only left side of the array. Then change high is equal to mid minus 1. So this process has been repeated until compare with all the left side of array elements or right side of the array elements, or the x element is present in which position. So this has to be, these are the steps of binary search. Okay, now we have to discuss with one example. By using these steps we have to discuss it right now. Example, array. Suppose there are some elements are there, 3, 4, 5, 6, 7, 8, 9. So total how many elements are there? 1, 2, 3, 4, 5, 6, 7. 7 element. Suppose the search element is, we are assuming x. Search element is x. We are given the name of the search element is x. Suppose that is equal to 4. So now originally we know that the 4 is present in the position 1. This is a of 0. This is a of 1, a of 2, a of 3, a of 4, a of 5 and a of 6. Right? So we know that the search element x is present in the position 1. So now we have to calculate that. So first step, what is low? Low is equal to initially 0. We know that low is equal to 0. That means what is a of 0? Is 3. A of 0 is 3. What is high? I means n minus 1. That means last element. What is the last element is? Last element 0, 1, 2, 3, 4, 5, 6. So 7 elements. So a of 6 is equal to 9. So we need to calculate mid. So what is mid? Low plus high by 2. What is low? 0. What is high? High is 6. 7 minus 1, 6. So 0 plus 6 by 2 is equal to 3. 3. So now, what is a of mid? A of mid is equal to a of 3 is equal to 0, 1, 2, 3, 6. Right? So we know that what is low, what is high and what is mid. So now we need to do the comparison. Right? So comparison. Now what is low? Low is equal to 0, high is equal to 6, mid is equal to 3 and a of mid is equal to 6. So now x, what is x? X is equal to 4. So if a of x is less than with a of mid, right? A of x is less than with a of mid, then what we have to do? We need to compare only left side of the array. So not need to do the right side of the array. Now onwards, so we have to eliminate, we are not going to discuss about right of the array. So only just we have to discuss about the left side of the array. So a of x means, what is a of x? 4. 4 less than 6. Then what we are going to change? Then change high is equal to mid minus 1. What is mid? 3. 3 minus 1 is equal to 2. 3 minus 1 is equal to 2. So now we need to take only left side of the array. Now we have to take only left side of the array. Left sub array. Simply we can call left sub array. So what is left sub array? 3, 4, 5. Only 3 elements. So now where is low? Low is equal to still 0. This is low. Where is high? High is equal to 2. This is high. Right? So now again we need to calculate mid. Okay? So this is up to the second step. So now again we need to calculate mid. So what is mid now? Low plus high by 2. That means 0 plus 2 by 2. So that means mid is equal to 1. Right? So now next step. Left sub array is 3, 4, 5. This is low, this is high, this is mid. Now what is x? X is still 4. So now if a of x is 4, sorry, not a of x is equal to 4 and a of mid is equal to 4. So x is equal to a of mid. So then we need to display the result as the element X is present in position. What is the value of mid? Mid is equal to 1. Position 1. So this is the output. This is about this binary search. This is binary search can be also used two methods. One is iterative binary search. Second one is recursive binary search. This is called as iterative binary search. Simply we can call this is iterative binary search. Right? So this is about iterative binary search. So now we are going to write a C program for iterative binary search. Iterative binary search C program. Using functions, whenever we are going to discuss about any searching or sorting methods, we have to go with functions, right? So now I am going to write the program for this one. So what is the first line of the program? Every time I am going to discuss about hash include stdio.h. So this, by writing this header file, then we can use printf and scanf in our program. So first of all, we have to discuss, we have to declare the size of the array at the time of execution. So here simply I am going to take int n. This value n should be entered at the time of runtime execution. So whenever we are using functions, we need to take a temporary variable I, and we need to search element is x, right? So next, finally, we have to display the position, so POS, right? So first we have to discuss about size of the array. Enter size of the array. Size of the array. Why we are taking size of the array? Because we are not wasting the memory. Scanf %d address of n. Suppose n is equal to 5, then int 5 elements. N is equal to 6, a of 6. N is equal to 7, a of 7. N is equal to 10, a of 10. So we can take only 10 elements. Depends upon our example, right? Right? Right. Now we declare the size of the array is a of n. Right? We take in n value and we are declaring int a of n. That is over. Now we need to enter the array elements. Printf /n enter array elements. So how to enter array elements? Suppose n is equal to 10, we need to enter 10 elements. So not need to write 10 scanf functions. We have to use a loop. Simply for I is equal to 0. Always array index starts with 0 and array ends with size -1. Less than or equal to n minus 1. Sorry, less than or equal to n minus 1, or simply we can write less than n. I plus plus. So now we have to enter the array elements. Array elements %d address of a of I. Suppose 5 elements, we can enter 5 elements. 10 elements, we can enter 10 elements. So we finished size of the array and enter of the array elements is over. Now we need to enter the search element is very important. Printf /n enter search element. What is our target? This search element is present in that array or not is our target, right? So scanf %d. Already we taken this name of the variable is x, right? X. So now we need to call the function binary search. Position is equal to binary search in an array in number of array elements and x. So we need to pass the elements are array name and array size, and at the same time search element we need to pass, right? If this position equal to -1, what is the meaning of this one? Position equal to -1 means the search element is not present. The search element is not present. not present. Suppose else, that means the search element is present, then ఎంత టైం వచ్చింది else printf. So now we need to display the search element is present in position percentile d. What is that? POS, right? So now return 0, close this function. Now we have to write the code for binary search. Binary search. So what are the array, what are the elements? First one is array name, int a. Next one is array size, next x. So I am going to take simply I. So now we have to calculate now low, high, mid. What is low? Already we know that low is equal to 0, high is equal to n minus 1. Already we know the size n value, and mid we need to calculate. Mid is equal to low plus high by 2. So we know that what is low, what is high, and what is mid. So now we have to write, we have to do the comparison now. If x is equal to a of mid, that means the element is equal, the x element is matching with the middle element, then return mid. Else, suppose this is not equal, else if x is less than a of mid, then we have to do less than a of mid means what we are going to do, what we need to change, we need to compare only left sub array. That means high has been changed to high is equal to mid minus 1. This is also wrong. Else high is equal to, so not high, low is equal to mid plus 1, right? Suppose this is all wrong, then we are going to return minus 1. Close. So this is about iterative binary search C program.